everyone, I am so glad you could... Whoa! Okay there, buddy. As I was saying, I'm so glad you could join me today. As you might have noticed, I'm at the zoo. My friend Caroline has a job here, and guess what? She's been using a lot of math to help make sure that the animals and the guests are as happy as can be. I'm hoping that we can help her out today now that we're slope-intercept experts. Let's get... Geez, on second thought, let me meet you somewhere a little quieter so that we can get to work. That's much better. As I was saying, Caroline needs our help. Let's start with the food budget. There are a lot of predators at the zoo, and they all eat a lot of meat. All that meat costs a lot of money, so Caroline wants to keep a close eye on the budget. Every week, a fresh delivery of meat comes in from the supplier. Meat costs $2.65 per pound, plus there's a delivery fee on each order. The problem, however, is that Caroline doesn't know how much the delivery fee is. We do know that last week's delivery cost a total of $12,986.50 for 4,750 pounds of meat. It sounds like a lot, but trust me, we don't want to see what these guys look like when they're hungry. We know by now that to write a linear equation in slope-intercept form, we need a slope and a y-intercept. But now we have to find that information from written sentences instead of tables or points. To do that, we're going to have to talk about what to look for. When we're working with tables and graphs, they told us what x and y were. But now we're not just talking about coordinates. Now they have meaning, and they represent other things like money and meat. So we have to think a little more to determine what x and y are. First, we should figure out what the variables are in this situation. Remember that variables can have changing values. So to find the two variables in this situation, we can ask ourselves, what two things can change from week to week? We can buy different amounts of meat each week, which also means that the total cost can change from week to week. So the two things that vary from week to week, also called our variables, are the amount of meat and the total cost of the order. Now the question becomes, which one of these is x and which one is y? This brings us to a new concept, independent and dependent variables. Flip to the second page of your guided notes so that we can talk about them together. In situations like this, one variable is often affected by the other one. You can think of this kind of like cause and effect. Considering our two variables, does the amount of meat Caroline buys affect the total cost of the order? Or does the total cost of the order affect the amount of meat Caroline buys? Yeah, the amount of meat that Caroline buys affects how much the order costs. That's because the amount of meat is the input in this function, also known as the independent variable. The independent variable is always going to be x. The variable that's being affected is the output, or the dependent variable. In this case, what's the dependent variable? The total cost, because the total cost depends on the amount of meat ordered. The dependent variable will always be y, so we found our variables. It's important to stop and identify your independent and dependent variables so that you know what x and y are. After all, how are you supposed to identify important attributes like the y-intercept if you don't even know what y is? Speaking of y-intercepts, all of the other ways we know to identify the slope and y-intercept can still apply here, but there are some new ones that are specific to application problems too. In addition to being the y value when x is 0, the y-intercept can also show up as a starting point in a problem, or a one-time event, like a fee. The slope, in addition to being the change in y over the change in x, can also show up as a repeating event. Let's take another look at what Caroline needs help with, keeping this in mind. Here's the full text of the problem we've been investigating. First, we need to write a slope-intercept equation to represent this. We know that x represents the pounds of meat, y represents the total cost of the order, and meat costs $2.65 per pound. And that last week's order cost $12,986.50 for 4,750 pounds of meat. Do you see anything in here that might be a slope or a y-intercept? Well, the y-intercept would be a one-time thing like a fee, or if we think about when x is 0, it'd be the total cost of the order if Caroline ordered 0 pounds of meat. Okay, I know that sounds a little silly, but imagine it for a second. If she wasn't paying for any meat, what's the only thing she'd be paying for? The delivery fee, which is also just a one-time fee for the whole order. So it makes sense that that would be our y-intercept. Okay, that's really good to know. But also, we don't know what the delivery fee is. That's the whole problem. Whoops. At least we know what it represents now. What about the slope? Do you notice anything that might happen repeatedly, or a number that represents the change in cost over the change in pounds of meat? That sounds a little weird still. Okay. If we think way back to translating expressions, remember that a fraction bar can also be read as per. So that would make this fraction the change in cost per pound of meat. Okay, that makes so much more sense. How much does each pound of meat cost? $2.65. So the slope is going to be 2.65. Application problems can take a while to get through, so it's always good to stop and take a look at your work once in a while. We know what x and y represent. We know what the slope represents, and that it's 2.65. And we know what the y-intercept represents, but we don't know what number it is yet. Our ultimate goal is to figure out how much the delivery fee is, which we now know means we just have to find the y-intercept from this equation. Think about everything you've learned about writing slope-intercept equations so far, and everything we know about this scenario. How do you think we can find the missing y-intercept to determine how much the delivery fee is? We could substitute a point and then solve for b. Do we have a point? Actually, yeah. Last week's order is actually a point. But be careful. Make sure that you use the amount of meat as x, since that's the independent variable, and the total cost as y, since that's the dependent variable. That makes the point 4,750, 12,986.50. Pause the video now and use this point to substitute and solve for b, the delivery fee. If we substitute 4,750 for x, 12,986.50 for y, we can simplify and subtract from both sides to get b by itself. And we get that b is 399. Now that we have b, we can write our final slope-intercept equation. But more importantly, we can help Caroline. How much is she being charged as the delivery fee for her weekly meat delivery? The fee is the y-intercept, so $399. Wow, that is expensive. But I guess it's not easy to pack up and deliver almost 5,000 pounds of meat. That weighs as much as a fully grown rhinoceros. Okay, I just threw a lot at you there, and it will take time and practice to really master slope-intercept applications. But the good news is that Caroline needs a lot more help, so there's plenty left for us to practice on. This time, we get to help plan out a new sloth habitat. You can find the full text of the scenario in your PDF. But basically, Caroline Zoo is going to be taking in a pair of sloths from a rescue, so the zoo is planning to build a new habitat for the sloths. They want to make sure that the habitat is big enough for the sloths to be comfortable and big enough that they have room to have sloth babies. The sloth habitat needs to be 600 square feet for the pair of sloths to live comfortably. But for each baby sloth they have, they'll need an additional 350 square feet. Of course, we're going to have to write a slope-intercept equation to help us out. I want you to start by figuring out what the variables are in this situation. Pause the video here and identify what two things can change in this scenario. The two things that can change are how many babies the sloths have and how big the habitat is. And which of these is independent and which is dependent? Remember, the independent variable changes on its own, while the dependent variable changes because something else happens. Well, the habitat has to get bigger if there are more baby sloths. So the size of the habitat is dependent on the number of sloths. This means that the number of sloths is the independent variable, or x, while the size of the habitat is the dependent variable, or y, since it depends on the number of sloths. Using the variables we've identified and the information from the scenario, pause again here and try to write a slope-intercept equation to represent this. Now that we know the baby sloths are x and the size of the habitat is y, we can see that this starting point of 600 is our y-intercept. If the sloths have 0 babies, they still need 600 square feet. Now all that's left is the slope. The only other thing that we have here is that for each baby sloth, we need to add 350 square feet to the habitat. Is that the slope? Yeah, it is. If that didn't click for you right away, we know that with 0 babies, the sloths need 600 square feet. If the sloths have 1 baby, how big does the habitat have to be? 1 baby means adding 350 square feet to the habitat for a total size of 950 square feet. With these 2 points, you could use the slope formula to double check and see that yes, our slope is in fact 350. And actually, that's it. That's the slope-intercept equation. Nice. But there is still one more part of this. If the zoo makes the habitat 1,500 square feet, how many babies can the sloths have before they run out of room? Pause this video one more time and try to solve this last part on your own. Remember, the size of the habitat is the dependent variable. So we can substitute 1,500 for y and then solve for x, the number of baby sloths that will fit in that size habitat. Isolating x tells us that a 1,500 square foot habitat can fit about 2.57 baby sloths. Somehow I don't think the zoo would like it if we said that the habitat could fit 2.5 baby sloths. So how many baby sloths can actually fit in this space? Only 2. We can't round this up because 3 sloths would be more than 2.5, and so they wouldn't all fit in the habitat. Instead, we have to round down to be realistic in this kind of application. You've been working so hard in this unit to learn all about slope-intercept form. It's great to be able to pull it all together to see how we can use linear equations to help in the real world. When you start an application problem, it's a good idea to pause and identify your variables, including which is independent and which is dependent. Be on the lookout for which things can change in the scenario and which variable affects the other to help you. Sadly, we've reached the end of this video, but Caroline still needs a lot more help from us. Once you're finished with your guided notes, head to the additional practice in your PDF to work on some more zoo applications. You'll need to work on the additional practice to be able to complete your last task for this lesson, the online practice game. As for me, well, I'm headed to the otter exhibit next. I just can't get over how cute they are. Guess I oughter hurry over before the zoo closes. I'll see you next time.